Hey there, it's me again, and it's you again, which means it's time for algebra again. Let's get rolling. Let's not dawdle. Still in Unit 7, we're jumping back to technically their lesson number 9, but it doesn't really matter that we're kind of out of order, because quite frankly, sometimes my ways are better than their ways. We are factoring polynomials still. Specifically today, it's trinomials, right? So it's going to start with 3 terms. And maybe you're thinking, Glessner, we've already done this. Kind of, we did. Last time we factored trinomials, we did it the long way, right? And it's going to be the long way again. But last time we did this, that number there was always a 1. It was a 1x squared. And that made, actually, believe it or not, that made our problems a little bit easier. So today, these trinomials have an a attached to the x squared. And specifically for a, it's going to be a number other than 1. And all that means is it's going to change, well, actually, I guess it changes quite a bit. But let's not forget, these are the important questions you should be asking as you're factoring. Can you factor anything out? Do you have 4 terms? Do you have a difference of squares? We haven't done perfect square trinomials. Don't worry about that yet. But ultimately, we're going to be down here in this mess. We're going to be back doing this the long way. And specifically, this is the new part today. We're going to be looking for 2 numbers that add up to b and 2 numbers that have a product of a times c. So you're going to have to remember today to take that a times that c when you're breaking down and looking for your factors. Now, let me show you my way. Let me say something before I go any further. Okay, listen. Very seldom in math is there ever just one way to do something. No. Usually there's multiple ways. So if I show you this process today and you think, gosh, there's got to be an easier way, you know what? Knock yourself out. There are other techniques and approaches to doing this factoring. You can get on probably Khan Academy and find some of your own. I'm going to show you always what I think is best. Because what I think is best and what makes most sense to me is what I'm going to be able to explain the best to you, right? So I'm just telling you, this isn't the only way to go about this. It's just the way that I like, okay? Let's see what we're talking about here. Example 1. Check this out. We start with 2x squared plus 5x plus 3. Now, before I go any further, ask ourselves, can we factor anything out? No. Do I have 4 terms? Not yet. But you're going to have 4 terms. You do not have a difference of squares. We haven't learned about perfect square trinomials. Okay, factoring the long way. That's ultimately what we're going to have to do here. It's 2 numbers that add up to b. This is b. Same 2 numbers multiply to get the same value as a times c. So now we're going to have to take a times c. So check it out. What adds up to a positive 5 that also multiplies to get 2 times 3, which is 6? Right? Where'd that 6 come from? 2 times 3. Can you think of what it is? It's 2 and a 3. Both positive. Now, originally I said you don't have 4 terms. No, these are trinomials to start with. But you're going to turn it into 4 terms. You're going to take this middle term, this 5x, and you're going to break it down into a 2x and a 3x. Watch. So that's the only thing I changed. I changed that plus 5x into a plus 2x and a plus 3x, right? That would make a 5x. Where did the 2 and the 3 come from? They came from over here, from our factors. Now guess what you've got? You've got 4 terms. And when we have 4 terms, kids, we group. It's just what we do. What can come out here? A 2x. That would leave behind a 1. No, it wouldn't. Yeah, well, a 1x. And a plus 1, which is what you want to have left over here. So you'd have to take out a 3, right? Now, the outside stuff goes in one set of parentheses, and the matching set goes in the other set of parentheses. And there you go, final answer. We factored that trinomial with a leading coefficient of a number other than 1. It was 2. Cool. Let's do another one. Example 2. 6y squared minus 5y minus 4. Okay? Can you factor anything out? No. 4 terms? No. Da, 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 blah, 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 blah. Long way. 2 numbers that add to negative 5. 2 numbers that multiply to get negative 24. So you got to be good at your fact families to make this come together. And sometimes this right here, I guarantee you, this is where you're going to spend most of your time thinking. Like, geez, what would multiply to negative 24 but add to a negative 5? I'll tell you, it's a negative 8 and a positive 3. I just had to sit and think that through myself. So that's just part of algebra, right? Understanding fact families and number relationships. So these become your middle terms. Right? 4 terms. Grouping. What can come out of a 6y squared and a minus 8y? A 2y can come out, leaving behind a 3y and a minus 4, which is exactly what we want to have over here, right? We want those to match. So what do I need to take out of this to get to this? The answer is a 1, right? I mean, basically nothing. Well, you do though, because we need somebody to buddy him up with. So you would like fake it, right? You fake factor out a positive 1. That wouldn't change anything, right? Because it doesn't need to change. But you need to have something to pair up with this other outside piece. So that's where you really have to understand, yes, these need to match, but Glessner, it already matches this. Okay, well then you better bring a 1 out. Okay, it's like a placeholder. So now you have in one set of parentheses this, and in the other set of parentheses this. Those are your 2 factors of that trinomial. Okay? Let's do another one. Actually, we're going to do quite a few more. Yah-dee-da-dee-da. Let's do, this is technically example 4. Don't get too worried about that. I don't know why I always say that, because I don't want to confuse you, I guess. Can't factor anything out. You don't have 4 terms. It's not a difference of squares. Blah, 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 blah. Factor the long way. What would add up to a positive 11, but multiply what's 12 times negative 5? To a negative 60. Oh boy. I had to sit and think about this one for a minute. I had to think about everything that multiplies to get, negative 60. Here's what I came up with. A negative 4 and a positive 15. Right? Yep, that's it. These become the middle terms. Don't forget to put those C's on there, right? I know here they don't have C's, but when you're taking this, they each get the C. You break it apart. Okay, 4 terms is grouping. What can come out of 4C? That's what we get left behind. This to match. So I must take out a positive 5. Leaving behind Your final answer, 4c plus 5 in one set of parentheses, and a 3c minus 1 from the twins, the matching set of parentheses. There you go with that. You know, why do you think I call it the long way? You figure that out? It takes forever. That's why. Let's do some more. Yeah. Ooh. Oh. Watch it. Watch it. Check this out. I always wonder if you can hear my music, but no. I actually have my music playing in the background. It's my classroom playlist. I don't know if you can hear it or not. Here we go! Oh, kids, 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 kids. First question. First question. Can you factor anything out? Yes. Yes, you can. So do it. They can all give up a 5. So you factor out a 5. He stays out here. He ultimately just is like a tag along. He's going to come along for the ride all the way down, and he will be part of our final answer. Now, blah, blah, blah. No, you can't factor anything else out. You don't have 4 terms yet. If you don't have a perfect square trinomial, blah, 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 blah. It's factored the long way. From here, now we're going to look at this trinomial and factor it the long way. So I need 2 numbers that add up to 15, that multiply. 2 times 7 is 14. You know what it is? You probably do. That's not a very difficult one. It's 14 and 1. So, comes along for the ride. I have 2k3 plus 14k plus 1k plus 7. Right? There's the 14 and the 1. 4 terms is grouping. So now this and this and this and that. The 5 comes along for the ride. You just kind of like, I don't know, put him in a bubble. Make him sit out there for a little while. I don't know, whatever. He's out there. Don't forget about him. What can come out of a 2k3 plus 14k? A 2k, which would leave behind k2 plus 7, which is, what did I do? Now I feel like I messed something up. Did I write this? Holy moly, you guys. Lesnar, oh my gosh. Guess what? Watch. Watch. 2. I wrote it down wrong. Would you believe this? Look at this nonsense. Sorry. Change these all to 2s. You know what? I'm a human being. What are you going to do about it? What are you going to do about it? It's a 2. Guess what? This is junk. Junk. And I'm not going to restart this recording. Okay. So sorry. That should be a k squared, k squared, k squared. I'm sure some of you are like, what are you doing? It's okay. It's all right. All right. Let's go back here. What can come out of a 2k squared and a 14k? Okay. Now we can take out a 2k. Oh, there's our 5. Remember, he's out there. So we still take out the 2k, leaving behind, though, a k plus 7, which is what we want to have match here. K plus 7 matches. Oh, it already is a 1k plus 7. Okay, but remember, you need that placeholder. Bring out that 1. So now you have a5 outside. You have the outside stuff in parentheses and the matching inside stuff. So that 5 is part of our final answer. We have to remember to bring him along. Let's do another one like that where I hopefully don't mess anything up. Yeesh. All right. Bear with me. Which one? Oh, let's do this one. It's technically 14. 32. Hey, guess what? It's x squared minus 16x plus 2. Question. Can you factor anything out? First question, the answer is yes, you can. They can all give out or give up a 2. So a 2 comes out, leaving behind 16x squared minus 8x plus 1. From there, focus on that trinomial. I'm going to tell you right now, it's factored the long way. Has to add up to a negative 8, but multiply, what's 16 times positive 1? Positive 16. So what would multiply to get a positive 16, but add up to get a negative 8? Negative 4, negative 4. That would make positive 16 and have a sum of negative 8. That's what's up. So now these become your middle terms. You've still got this bonkers 2 sitting out here. He's going to get in his little cloud. All right, there are my 2 negative 4s. So now I have 4 terms and I'm going to group them. There's my little 2. What can come out here? A 4x, leaving behind a 4x minus 1, which is what I want to have here. They need to match. So how do I get from this to here? I take out a negative 1. Final answer. Outside stuff? Outside stuff. What? Wait. Yup. That's true. Our outside stuff was a 4x minus 1. And our inside matching term, parentheses was 4x minus 1. And you know what? This is A-okay. I would be thrilled if you could get that. But if you're really feeling like, hey, I'm really going to go be as cool as I can here, you could do this. You could show that you actually have 2 of those by just writing it once and using an exponent of 2. That certainly isn't incorrect. Okay? See, now I'm at a point where I'm on the fence. I'm like, should we do another one? Do you feel like you've got it? Will you remember to ask yourself the first question? And I'm sure you get why I call this the long way. Because look at how long this is. You go from here to here. And then from here, we kind of jump over here and grab these numbers, which then come in here. Well, now you've got 4, so you break it down, you do grouping, and you factor all that mess. Then the outside guys go here, and the inside guys go here, and oh, geez Louise. Right? I mean, it's a lot. Nobody ever said algebra was easy. But I think we're good. I don't feel like I need to show you anymore. You know what? If you're still struggling, maybe we can do another example, or I could do a Google Meet with you and we could work some out together in real time, okay? But let's be done for now, all right? I hope it makes sense. I hope you're doing well. Be in touch as needed. Take care. Bye-bye.